Welcome everybody to your labs, where everything is done online and you watch it all through YouTube videos, and then you're forced to complete a worksheet at the end while paying them $6,000 just to create your crappy worksheet. Alright, let's continue. Okay, so for question 1, this is pretty simple. You're given all the data. You basically need to rearrange the data to make it a little more presentable. So what are we going to do using Excel? Basically, yada, just copy paste this, copy paste. As you can see, I've already done that, so no need to waste time. Okay, so what you're gonna do is you're just gonna drag and control. You're just gonna control. Hang on, that looks bad on OBS. Okay, yeah, just control. God damn it, stay still. Holding control key like that. Drag like that. Okay, we're gonna go to inserts. You see the scattergram? Click down, click this one. And would you look at that? You got everything you need, okay? Include axis titles. I'm not going to fill this in, obviously. And then tread line. Okay, more options. Give me 1 second. Ding ding. We'll just leave that right there. Okay, if we've got everything, we got everything. Also, get rid of that. Boom. Okay, so the thing was asking for lag base, exponential, and stationary. Okay, so what I'm gonna do, just draw this. We'll call this the exponential phase. This is the log. Because look at that, exponential growth. I don't know, basically I'm just bullshitting here. And then this will be the stationary phase. So that's stationary. And then last but not least, green. That's the lag. Basically, because this is a straight line, this boomed growth, and then this like this. More towards the end, but for now, this is all you're required to do. And then so yeah, good job. Okay, for number 2, this isn't really explained, but all you need to know is that you need to solve this somehow, and the way to do that is through OneNote. So basically, if you remember watching one of my previous videos, dilution factor is equal to dF equal to initial volume divided by final volume. Links to these videos will be given in the description below, but basically, just to oversimplify things, the dilution factor from the previous problem was 1/50. I just simply set x as that because that's a v of 1. Just simply like that. And then the final volume is 1 milliliter. You can see that right there. Dilution factor 1/50. So all you do is just simply cross multiply. And then eventually you'll get this as the end result, where x is on one side, the other is on the other side. So 1/50, you get this, and then to find the, which is what I want, which is sample volume, and then the dilution volume is just simply this. And so if we continue from here, we go to B, 1 in 200. But the way it wants you to do it is first, 1 in 20, then 1 in 110, which is super confusing. Okay, I'm not going to complain. It makes life difficult, but that's the way it is. Like, fuck the worksheet, that's just the way it is, okay? So we do the same thing as we did in step 1, except it's 1/20 because that's a dilution factor. Basically, rinse, wash, repeat. We have this instead, okay? This is like 0.95 ml. I know that isn't clear, my bad, and that can't be helped. And hopefully you can read that. But when going for the second dilution, you see this? This changes. That's because we can't do anything fancy schmancy. We're practically using that 0.05 as the final volume here to do it here, because if you were to reverse the process and do 200 here, it should give you the same answer. So you follow through, and then there you go. That should be your final answer right there, with this being your answer as well. You get the idea. Okay, and then going back, that's how you do it. And then C, like here for the tutorial, blah, 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 blah. Okay, so basically, click here for the tutorial. Credit where credit's due. I'll just show you the quick and easy version. Let me just get rid of this real quick. Oh god. Oh god, the lag. Oh. Oh wait, oh, I destroyed the data. Let me just, yeah, thank you. Let me get rid of that. Okay. So we're gonna do the same thing here. Drag, hold the control key, drag like this again. What is it? Insert right here. Scattergram. Oh yeah. Just delete. Axis titles. Don't forget your axis titles. And why? No. Okay. Red line. More options. Still linear, but I want equation and that. Ooh, that's so nice. That's so smooth. Basically, control paste that into your thing, but yeah. So basically, the question tells you already that background has been corrected, so no need to repeat the way the video did it. And then so from here, what we're gonna do is just simply drag this over here. And as you can see, since we know the y, we want to find the x because 0.95 is around here, and it should give us some value, while 0.23 is yeah, right about there. We're probably with it, no, a little lower than the dot. You get the idea, okay? So we're gonna have to reverse the process. So basically, since we're trying to figure out for x, we're gonna have to rewrite this equation. So it's basically gonna be equal to, just click this, which in my case is I13. I would put a bracket around it. Okay, so you would minus 0.0272, which is the y-intercept. Close the bracket and divide it by 0.1085. There you get your answer. And then boom, you bring it down. Okay, so there you go. You get your concentrations. Bada bing, bada boom. Don't worry. I literally looked this up. It's okay with you using this way to calculate the concentration. And so from there, it says, don't forget the dilution factor. So as a big F you, basically what this is saying is equal to this divided by 50, which was the first one. And then this divided by 200, which is the second one. There you go, nice and easy. Bada bing, bada boom. That's your two final answers. Obviously, you're going to have to justify and explain this, but that's the long and short of it. That's the end of this worksheet. Hopefully you enjoy. I know I did this late. Listen, okay, the file got corrupted, and this is when I can start bullshitting, okay? This is simply when I can just start bullshitting. But yeah, I'm sorry it took so long, but this is how it is, okay? So if you don't know anything that's going on right now, this is optical density, okay? This is the formula. Many of the YouTube videos that I'm going to link in the description below will help with this, but basically, long and short, this is the formula. In case you're given this and this, and you need to find C, well, you can't, okay. In all the scenarios, you're given all three of these, except for C, and that's what you got to figure out and work around. So, spectrophotometer, big word I can't say. Common use for UV and visible spectrometer. Basically, we use it for E. coli growth. That's basically what it is. And of course, we got to make it sure it's sterile and under optimal temperature. So what's the point of this? Basically, standard growth curve, model shape. No idea what that means. So we're basically plotting the curve, observance versus thing, which was the first thing we did. No, that's not the first thing we did. I think it's this one. Yeah, it's that one. Versus, nope, never mind. It was the first one. It was the first one. Yes, because there's no way we're going to count every single one of them. Okay. So the conclusion here is as this number of cells and size increase, the number of particles in suspension also increases, and the more light is scattered, less light arrives at the detector. Light is deflected or reflected as it increases in absorption, okay? So, what does this mean? Well, there are three phases, okay? Phase 1, the lag phase. Some environmental BS, okay? It's just some environmental BS. Stage 2, the log phase. Basically, log levels like of increasing rapid division without sex. Stage 3. Also, we're going to place a heavy emphasis on this. You might get debated by this. Be careful, okay? So yeah, if you have like n is equal to 2480, you basically got to do the reverse log of that. I believe is 10 to the power of 11. Yep. So that's the 11th generation. Whatever. Okay. Stationary foods. No food, no growth, no sex. Basically what it is, okay? Basically it becomes too hazardous, kind of like what we're doing, and it's unfavorable environment for bacteria. I wonder where I heard that from. So basically the rate of sex apparently equals to the rate of death, slowly favoring death or shifting it towards its favor, and there was no longer anything, okay? Fourth is death phase. Decline sounds too nerdy, okay? Literally no sex. It's only genocide. Mass murder without a serial killer. They basically did them to themselves. It occurs in a death and uniform rate. I don't know what this means. Death is just organized as fuck, okay? And then, yeah, that's basically what this means. So, moving on from the basics and more focusing on to this specific thing, we continue on, and we see that we are measuring the quantity and quality of DNA and RNA, okay? So basically, when we're doing it on OD260, it's easier to calculate, okay? I'm going to link a YouTube video in the description, don't you worry. This makes it simple. This makes it more simple. Fun fact, scientists enjoy studying your shit. Shit equals bowel movement. Trust me, do not look this up. If you did, you're nasty. Okay, so nucleic acids. We put it in a buffer. We shoot it through a light beam. And then we find our results. So basically, these numbers didn't come from nowhere. You're going to do some random sample calculations, but this is more expected towards the exam. This is going to get me screwed. Okay. So there are a number of ways of doing this, but we'll focus on BAC for now because it's basically spectrometry for dummies, undergrad college kids. Okay. So in the presence of it goes from a green color to a purple color. The more of the protein that there is, the deeper the color. Obviously, the product absorbs light maximum. Dude, I have lost my voice and I don't know why. I haven't talked at all today. Okay, so why is this important? The black market messed up with your shit, your tubes, and so you got to figure it out, okay? And in order to figure this out, you somehow need to involve grade 9 mathematics. Basically, you give this to a 9th grader, he could figure this out. Trust me, I've tried this. So you use this, calculate for the unknown absorbance. Basically, ignore all of this. This is just yammer jabber. And if there's anything you haven't understood, use it to a video going more into detail. But other than that, that's the end of the video. Thanks for watching. Toodaloo.